Hi everyone, and welcome to our video on finding coterminal angles given radian measures. Okay, so all of these are in radian measures here. Well, it's just like it was in degrees. With degrees, we added or subtracted 360 degrees. With radians, we'll do addition or subtraction with 2 pi. Okay, because on our unit circle, let's go and sketch just a little bit. So on our unit circle, we know that going around one full revolution is 2 pi. But if we go around again, let's do that in red. If we go around again, so 1 and then 2, well, that's 2 pi and another 2 pi, so that's 4 pi. And that's coterminal with our original 2 pi. So again, it's just showing every time we add or subtract 2 pi, we're going to be put in the same coterminal spot. All right, so let's find these. So find a positive angle less than 2 pi, and then find 3 others. Okay, so kind of like the previous video, we kind of have 2 parts, A and B. Okay, so 13 over 6. So notice 13 over 6, we can estimate, or I'm going to estimate it. Notice like 12 over 2, or 12 over 6, there we go, is 2. Okay, so that's the coefficient part. Okay, so 13 over 6 is a little bigger than 2. So what we would do on this problem is just subtract 2 pi. Okay, so we're going to minus 2 pi from this. However, we do need a common denominator. Well, that's quick to find. It's just multiply the top and bottom by 6. Okay, so we've got 6 and then 12 pi. So 13 pi over 6 minus 12 pi over 6 is just pi over 6. That's it. Okay, so pi over 6 is the same thing as 13 pi over 6 with angles. So they have the same coterminal point. Okay, so that is the part A. That's a positive angle less than 2 pi. And then now I'm just going to continue subtracting 2 pi. Okay, so pi sixth minus another 12 pi over 6. Again, that's 2 pi. I already have a common denominator, so I'm going to keep my common denominator. And that gives us negative 11 pi over 6. Okay, so this is going to be part B. So there's one of them. And then I'm going to take that angle again and subtract another 12 pi over 6. So you get a nice kind of pattern. Radians can be nice because they're usually with a quick pattern with the numerator and denominator. Okay, so this is negative 23 pi over 6. And then let's get one more positive angle. I'm going to go back to 13 pi over 6. And I'm going to add 2 pi. And I already have a common denominator. I know 2 pi is the same as 12 pi over 6. And then I can just quickly do that already. 25 pi over 6. So there's 3 other coterminal angles. Okay, so pi sixth. So this is where we might want to try to start getting used to pi's. We'll show how to measure them more often, or if we already know how to measure them, that's great. But you might want to convert it as well. If you do convert it, this would be 30 degrees in degrees. Okay, so our pi sixth puts us somewhere about there. Okay, so we'll just do our conversion for now for this to show the picture. Okay, so that's where 30 degrees is, or pi over 6th is. So let's mark it. There's pi over 6th. Okay, so there's the letter A marked. 13 pi over 6, though, all these others, I'm going to do the 13 pi over 6. 13 pi over 6 would be just like that. Okay, so I went off the circle a little bit so you could see it, but it just went one full time around, and then another little bit of pi sixth. Still puts us in the same coterminal spot. Okay, so still, just bolding it, still right there. That's it. Okay, so again, coterminal angles are just usually used to get something that's easier to work with. All right, however, this time they are making us find more than we probably really need. All right, let's do the negative 12 pi fifths. Okay, so negative 12 pi fifths, so it's negative, so we should add 2 pi to it. Just like the last problem, we should get a common denominator, so that would be to multiply by 5 on the numerator and denominator there. So we have negative 12 pi over 5 plus 10 pi over 5. And then that simplifies and gives us negative 2 pi over 5. Okay, so that looks like a part B answer because it's not a positive angle yet. Okay, so we do have at least that. But let's continue adding 2 pi, so negative 2 pi fifths plus another 2 pi. Again, I already have a common denominator. Let's just do 10 pi over 5. And that gives us positive 8 pi over 5. There's the angle that they wanted for A. Okay, and then letter B, I have one of the angles. Let's get two more. Well, let's just add another 2 pi. So 8 pi over 5 plus another 2 pi would be 18 pi over 5. Okay, so I'm going to cloud these since they're kind of in different spots. Okay, so the clouded ones are part B. And then let's add another 2 pi one more time. 18 pi fifths plus 10 pi fifths would be 28 pi fifths. There we go. There they all are. So all of these, again, are equivalent angles. All right, so that's that. If we do need to plot it, we could convert them to degrees. I'm gonna skip that for now. This is our focus, just to get the angles. Okay, one more time, number 3, 77 pi over 4. All right, so this again goes back to the multiples of 2 pi, because this would take too long to do that subtraction. Okay, however, okay, so a little quick thing to the side. However, first, I do want to convert it to have the same denominator. So I'm just to the side getting a common denominator and saying, well, 2 pi is the same thing as 8 pi over 4. And then comparing my numerator against some type of multiple, it looks like if I multiply 8 by 10, so 8 pi over 4 times 10, that's a multiple. So any integer, 2, 4, 3, 5, whatever. So I'm just choosing 10. I see that that is close to 77. Okay, so that means if we subtract, because it currently is positive, if we subtract by 80 pi over 4, that puts us in the ballpark of where we want to be. That is negative 3 pi quarters. Kind of like the last problem. That's not the one they want for letter A, but I'm going to cloud it and say, well, that's one I could use for letter B. And now that it's easier to work with, our numerator's close to 0, I'm just going to add. I'm going to go back to adding 2 pi, which is adding 8 pi over 4. Okay, so not a multiple of 2 pi, just 2 pi itself, which gives us 5 pi over 4. That's the angle that they're looking for letter A. Okay, because that's positive and it's less than 2 pi. Okay, because 5 over 4 is less than 2. So you're just comparing coefficients, and then the pi's just attached. Okay, and same with the letter A of the previous problem. The 8 over 5, the coefficient that's attached to pi, that's less than 2. So that's what they were looking for. Okay, and then now just two other angles. I'm going to add another 2 pi. So that's really adding 8 pi over 4, which is 13 pi over 4. So there's another radian measure for part B. And then one more addition. 13 pi over 4 plus 8 pi over 4 again gives us 21 pi over 4. There's our third one. Okay, and so the answers are not unique. You can have different answers than mine as long as it's adding or well, I guess except for part A. Part A, those are the correct answer. Part B, you can have any 3 angles as long as they're coterminal. Okay, so it doesn't matter. You can find other ones. Okay, but that's it for now. Thank you for watching. If you have any questions, please let me know.